Right, good morning. I hope you're all doing well. I just wanted to start today's lesson with a video where I'm going to get you guys doing a few more problems and thinking about vectors again. So I'm going to start with three IB questions, which are multiple choice. Now, I don't know how much you know about the IB exams, but at the end of year 13, you sit three different papers. Now, one of those papers is a multiple choice paper. Okay, and that sounds easy, multiple choice, you've got all the answers there, but actually they're quite tricky. So I'm going to go through three multiple choice questions. Okay, and in between each question, I'm going to give you a bit of time where I want you to pause the video, have a think about the question, and then we'll go through it and show you how it should be answered. So the first one should be quite simple. So, which of the following represents two vector quantities? Okay, now I'd like you to pause the video now, okay, and have a think about this for yourself. I know there are some words there that you don't necessarily know from GCSE. Most of them you should be familiar with, but you should still be able to answer this, okay? So if you can pause the video now and have a think about this. Okay, now the correct answer to this question should be question C. Okay, now both force and momentum are vector quantities. We should know those from GCSE. Being a vector quantity means that not only do you have a size, which is your number represented, for example, for force in newtons or for momentum in kilogram meters per second, but you also have a direction. So you could represent them with an arrow. Some of you might have gone for option A. Acceleration is a vector, but distance is not. Distance is a scalar quantity. Okay, the vector version of distance is displacement. So distance, any direction in which you travel, okay, any meters that you travel will become part of the distance that you record. But for displacement, we would only be recording the distance traveled in a particular direction. Anything related to energy is always scalar, so kinetic energy and work are scalar quantities. The two at the bottom are things you've not really come across at GCSE, okay, but hopefully by the fact that you knew about forces and momentum, you chose C. Okay, a little bit tougher question here. So the diagram below shows two vectors, x and y. Okay, so they're a vector, they've got a direction, they've also got a size. The length of the arrow tells me about the size, obviously the direction it points in tells me its direction. Now, which of the vectors below best represents the vector C that would satisfy the relationship C equals x plus y? So basically this is adding vectors together. If you've got an object and vector x and vector y, imagine them as two forces. So let's say you've got a force pulling in the direction of x, you've got a force pulling in the direction of y. What would the resultant force be? So C is like the resultant of the two vectors if we add them together. So again, can you pause the video here, have a think about this, and then in a moment, I'll go through the answer. Okay, so in order to solve this, to work out the resultant force, okay, from diagrams like this, the best way to do it is to take those forces and line them up from top to tail. Okay, now from top to tail means from the start of the vector to its arrow. So wherever x finishes, you're going to line up y. So we get a little vector diagram like this. So we line up x, and where x finishes, we line up y. Now, ideally, we want y to start exactly where x stops, which my diagram doesn't because it's difficult to do on here. But if you were drawing it, you would have it exactly at that point. Now, the resultant vector, okay, is always going to be one that joins the start of my first vector to the end of my last vector. So it's going to look like this. Okay, so my resultant is the one that would do exactly the same thing as x and y together. X and y together take me to this point, so the resultant must also take me to this point. So the correct answer for this one should be B. Okay, question 3. I think I might have done this with some of you that were in my class earlier in the year when we were doing forces, but let's have another go. Two forces of magnitude, so size, 7 newtons and 5 newtons, act at a point. Okay, so imagine there's an object at that point that they're pulling on. Which one of the following is not a possible value for the magnitude of the resultant force? So which one is not possible? So you've got two forces acting on an object or acting at a point. which of the following is not a possible resultant force? So again, you can pause the video until you've decided on what you think the best answer is, and I'll go for the answer in a moment. Okay, so in solving this, I'm just going to go through three kind of examples of how you can look at this before I come to an answer. So you've got two different forces, 7 newtons and a 5 newtons. So one of the ways of arranging them is you could say, oh, the 7 newtons is going to push upwards, the 5 newtons is going to act downwards, and in that case, the resultant force would be 2 newtons because they're acting in opposite directions. You're going to subtract the smallest force from the biggest force. Okay, now that's not the only way we could arrange them. We could arrange them both acting in the same direction as well. So if the 5 and the 7 act in the same way, the resultant force is going to be an addition of the two vectors. We're going to get 12 newtons. Now, those are the two where they're acting parallel, but what about perpendicular forces? Well, in this case, as we learned hopefully last lesson, okay, we would use Pythagoras' theorem here, and we'd say, well, the resultant force is going to be the hypotenuse of the triangle, okay, and so we do the square root of 7 squared plus 5 squared equals 8.6. Now, you might be thinking, yeah, okay, that's all very well, but how do I work out what the answer is? Well, if you look at these three diagrams, the biggest possible value I can get is 12, where the two forces act in the same direction. The smallest possible value I can get is 2, where they act in opposite directions. Any other direction, so I've put them at 90 degrees here, but I could, for example, have 5 going at 45 degrees to 7 or 10 degrees. But whatever angle I put it at, it's always going to be a value that's between 2 and 12, between the two vectors opposing each other and the two vectors acting in the same direction. So therefore, the answer to this is going to be 1 newtons. It's not possible for the resultant force to ever be less than 2 newtons. Okay, I could set it up at certain angles to make it 3 newtons, 5 newtons, 7 newtons, but it would be impossible to get it to be 1. Okay, so you didn't need to do the maths here like in this third one. Okay, you just had to realize that actually the smallest value you can possibly get is 2 newtons from one force subtracting from the other. So those are the three examples I want to have a go at. As we go through the next few weeks, I'll try and introduce you to a few more IB questions because you'll find that, they're often trying to catch you out a bit more than GCSE questions. And the questions can be quite difficult. Sometimes the English language in the question is difficult. And, sometimes they leave things in the question to trick you. Okay. So it's something that you need to get used to seeing. Before I get you guys to get on with doing your own independent work today, okay, I just wanted to remind you of something that we did in the GCSE course, and that is Newton's first law of motion. Now, Newton's first law of motion can be written in a number of different ways. Sometimes it's called the law of inertia. Okay, basically an object that's at rest will remain at rest unless an unbalanced force or resultant force acts upon it. An object that's in motion will continue in that state of motion. So that means with the same speed, the same direction, again, unless acted upon by an unbalanced force. Now, when I teach students about this, I sometimes write it in a different form now, okay? And the way I like to think of Newton's first law, just for simplicity, okay, is that if forces are balanced, there are two possibilities, okay? So if there is zero resultant force, balanced forces, it will either remain stationary if the object was stationary before the forces became balanced, or it's going to continue at a constant speed. Now, all through school, year 7, 8, all the way up to year 13, people still make that mistake that if the forces are balanced, they assume that the object is stationary. Okay, so hopefully you're already happy from earlier in the year that stationary is one possibility, but moving at a constant speed is another. Both of those are balanced forces. And obviously, the other side of that is if forces are unbalanced, well, it can't be stationary, it can't be at a constant speed, so something must change. So either it's going to accelerate, okay, or it's going to decelerate. The object will accelerate if the unbalanced force acts in the direction in which the object is moving, or if the object is not moving at all, it will always, obviously can't decelerate, it must accelerate. Or the object will decelerate if the resultant force acts in the opposite direction to the motion. Okay. Now, I've put some tasks on Google Classroom that I'd like you guys to work through today. Okay. One of them is a video about Newton's three laws, and it takes them beyond what we've done at GCSE and more into the realms of IB physics. Don't worry too much about the last couple of minutes of the video. It goes into some bits that we're not kind of ready for yet. So if you get past like 9 minutes in the video and think I don't know what's going on here, I'm not too bothered by that, as long as you're happy with what comes before that. Okay, so please have a look at the Google Classroom post now and work through the task that I've put on there. Okay, thank you. Have a good day.